Good day to you from Anagalactic on this 22nd day of July 2026. Today, as promised, I'll be going through the justification for producing a scientific paper which will be documented fully from inception, which is now. So you'll get to see the whole process. This is the follow-up to an experiment that was done 4 years ago here at this station, without a great expectation of the fantastic results after 4 years of documenting a discovery vector. I simply knew that this geometry that I discovered, which I will be documenting in this formal paper, I knew very early that it was going to lead to some fantastic applications. So very briefly, what I discovered is a new form of geometry, which has such extraordinary reach and extraordinary application that I will simply mention that it overhauls our number system right down to the operators and what it means to use a number. But it also goes in the opposite direction to the cutting edge of science in the philosophy department. It has direct application to the question of consciousness, which no less than Sir Roger Penrose has written 2 fucking books about. And I solved it. This also has application towards some fantastic framework research which has been going on. Bernardo Kastrup, who, if you check his homepage, which is well worth doing, he's quite prolific. He lists himself with 2 PhDs after his name. So he's not pretending. He's coming right out of the closet. He's extremely pretentious. But he's also quite humble. And I believe a scientist has to be both if he's making discoveries, which he has. He discovered a new framework for physics, which is based on consciousness. And that's revolutionary. That's much more important than Einstein's discovery of relativity, is Bernardo Kastrup's discovery of consciousness superspace framework. And I've perfected it. I found the flaw in his system and corrected it. And I call it, after his naming convention, he called it analytic. Analytic has the word anal in it. Analysis. Analytic idealism, which is a term taken directly from Plato's ass. And it's offensive to a certain rather uneducated or lower class of scientists. We're all susceptible to these idiosyncrasies, and we have to be tolerant of each other. Some of us are pundits, like Maudlin. Tim Maudlin is a fantastic pundit. He has to know it. But you see, you can also work that to your advantage as long as your audience is tolerant. Bernardo Kastrup really rubs some people the absolute wrong way. He rubs me the wrong way sometimes. But we all have to be tolerant of each other, especially at the cutting edge of science, where we're attempting to answer questions for all of humanity. The future of the human race depends on our work. And now I'm at the very cutting edge. Only it's too overwhelming for me to continue. After 4 years of documenting a discovery vector, it's no longer a vector. It's an entire universe of brand new discoveries. This is the beginning of a new age of science and of humanity. And it's my duty in the closing years of my life to somehow get out this information so that you, the listener, will carry on. My idiosyncratic drawback is very similar to Bernardo's and Tim's. My name is Scott, and my problem is megalomania. Raw megalomania. but I'm going to attempt to use it to advantage. I have produced, over the past 4 years, over 1,600 video presentations in science. I have gotten extremely good at it. The reason for beginning this channel was to document a discovery in geometry. Very simple. But I don't believe I ever would have gone to YouTube if I didn't realize right away that this geometry is going to change a lot of things in science which right now cannot be changed. I'm talking about answering the most basic problems in physics. Really not basic, but cutting edge. In other words, the natural boundary of what we know, we're always attempting to push that. Called pushing the envelope sometimes. You'll see I have highlighted down here intrinsic geometry, an amazing term, which you will not find any information on this except for one item that you can get from the Google chatbot called AI Overview. I accidentally discovered the absolute name for the geometry. It's a morphological classificational designator for the type of geometry that I discovered, which is curvature geometry. You can also say non-Euclidean. And there's a footnote to everything that I'm going to tell you, and so I want to just go through this in a methodical fashion so you will have a grip on what it is that constitutes this discovery and why the hell you might care. Very important to convince your audience in a scientific presentation of what does it mean for you personally. Because science is communicative, and your family members or your office mates or whoever you hang with, your peers, or just an abstract future of other humans, you're going to want to share this, or people are going to ask you what you know about it, and you've got to be able to give them a reasonable, perhaps even exciting answer. So what is so exciting about intrinsic geometry? That's what I'm going to be telling you today in this video, which is the beginning of a new series, which will run another 4 years if I live so long. Only this time it won't be merely documenting a discovery vector, but it will be documenting the production of a formal paper. And you've heard this term, paper. A paper is the absolute center of communicative science. It has to be in writing. The reason it has to be in writing, there are several reasons. One of them is obvious, is so you can read it. So you can read it in the privacy of your own home. You don't have to tune into my video station. You get my book or my paper, and you read that. Now, the layout for the dynamic aspect of what I'll be doing over the next indefinite period of time in documenting the production of this formal scientific paper, I will be documenting every single step, and nobody's ever tried to do that before. Indeed, nobody ever tried to document fully a discovery sequence. My discovery can be summed as a sequence. It's basically just 2 theorems, which establish the basis for a new kind of geometry. It's the circle instead of the Euclidean line. That is the absolute basis of my discovery, is to change objects at the axiomatic basis of logic, mathematics, and science, which is all based in geometry, which for 2,500 years has been Euclidean. So all of your physicists and all of your mathematicians are using a Bronze Age geometry. Bronze Age. So to get right into this, so you'll have something to talk about if you want to recommend my station to other people. I should be having soon hundreds of listeners, and then thousands, and then 10,000s, and then millions. That's my goal, is to get an extremely large viewer base. That may take forever, and I recognize that this is simply an idealistic projection, the best possible outcome. I don't have much time because of my age, but also because of my financial situation. I will never ask you for money. But I will be honest with you, I must confess to you, I do not have enough money to live. And I'm slowly being evicted from my premises. I can no longer pay my bills. $1,600 a month is not enough to live in the United States and produce a science channel. It costs me $10 a month to sustain a Wi-Fi connection. And it's quite possible that within the next few months, I may have to discontinue that $10 a month in order to stay alive and franchised, so I don't become one of the non-landed gentry. A more humane term for a hobo. And yes, I formally changed the meaning of the word hobo, on which I have been corrected by retards for way too many times. I am a precision logician, and I don't take prisoners. I can be extremely overbearing. I will correct people, at least in my mind, when they make a stupid grammatical error. I'm that kind of a nerd. I'm a geek, but I'm not a mathematician. I was tested at Stanford in 3 categories of intelligence as part of an experiment they were doing for a framework for intelligence rationalization. And I was tested in the field of language, as were many high school students. This was a voluntary experiment. I was tested for language ability, mathematic ability, and an abstract category, which basically was a bit bucket for what they couldn't squeeze into language or mathematic ability. I scored in the 99th percentile, in other words, at the top of the list in language. I scored miserably in mathematics, the 82nd percentile, which of course is upper class, but not good enough for Stanford. I was attempting to get into Stanford, although that would have been in the future. I didn't qualify. You can't get into Stanford unless you're a straight A student from kindergarten until the moment you apply to Stanford. You also have to be connected politically, or you don't get in. There have been exceptions, but those would be for geniuses, such as Ken Kesey, and there have been a few others. Basically, through a grant, because you have to be extremely rich to go to Stanford. However, I was so enamored of Stanford, just to give you a little background of my scientific nature. I used to ride my bicycle to Stanford hundreds of times, because it was only 10 miles away from where I was raised in the San Francisco Bay Area, the most beautiful and perfect place in the world to live, and don't try to live there. You can't now. But I was raised there because my father was a professional Major League Baseball player. And I was born in St. Louis because he broke into the major leagues with the St. Louis Cardinals. My 2 sisters were born in Philadelphia. You may have heard of the Philadelphia Phillies. So my 2 sisters are officially Phillies, and lovely ladies they are. Still around, still doing well. I come from a large family. My parents had 3 children, boom, 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 3 years in a row, back in the 1950s. So I am 71 years old. I am now a discovery scientist who's made a series of the most important discoveries in the history of science. So for you to have something to talk about with your friends and professors and professional interviewers, including radio and YouTube talk show hosts, you can talk about my work in this way: that I'm rewriting the Einstein space-time equation called the field equation. And you can also, if that's not enough to get interest, I have rewritten already the Einstein energy equation. The space-time equation is something I am working on now to rewrite it, but I will be showing you the basics of why it must be rewritten. It is an incorrect formulation, but it's superpositional. And superposition is one of the major discoveries of the 20th century. As you may know, Paul Dirac wrote an entire book on superposition, but only the first couple of dozen pages are written in human language. Because he, as David Bohm, as all of these men at the cutting edge of quantum mechanics, are forced to write, it's 99% absolutely indecipherable, incomprehensible mathematics, and both Dirac and Bohm admit it openly and freely at the beginning of their groundbreaking work. That is, their breakthrough publications, which were books. I am now capable and anxious, in a way, to write at least 3 books. But it's going to go way beyond just books. So that's one aspect of my work. You'll see also, and I'll be highlighting these in sequence. Let me bring that back up here. This is a Libre Office document you're seeing. What I'll be covering right now, beginning at this moment, is my discovery, what it is, and the applications. So you'll know why it's important. And I'll simply have to be telling you that without the explanation. The explanation, indeed, the description and explanation of the applications of my work are the subject of 1,600 videos, of which over 500 I've kept public. This was a learning process, and the first 1,000 videos, although of great value to me and perhaps for posterity when my work is reviewed. There is an archive of information of the entire process that I went through beginning 4 years ago when I began this YouTube channel in order to document what I strongly suspected was not only going to be a discovery sequence, but a discovery vector. What I mean by vector is that it's not just a single application. It's manifold applications across the board, beginning at the mathematical basis of science, which is really going back a long ways. This goes back to the beginning. I found Euclid's mistake in his very first statement. He didn't regress far enough in order to compose planar geometry. The discovery that I made is called intrinsic geometry, which is brand new. There has never been such a thing as intrinsic geometry. I urge you to look that up using your search bot, whatever it might be. There are several called chatbots, I believe. And if you type in intrinsic geometry, what you'll end up with is differential manifold calculus. And that is not intrinsic geometry. And that shows basically the status of science at this time in physics, at the mathematical edge of physics, which is redundant. They're psychotic. And that's a loaded word, obviously, to say that science is psychotic. I'm not the first man to do so. There are thousands of extremely astute observers, many of them broadcasting on YouTube, and really it's across the board. There's a general perception that science has lost its way. It has at all levels, and I can correct all of it. I can put science back on course. And in fact, this has a humanitarian application at several levels. At a certain age bracket, the educational phase, which is from about 5 years old to about 18 years old, where you're being educated because you're coming out of a raw unconscious state. So your society has to program you in some way to live as a human. And so you're brainwashed, and that's the right term for it, but it's beneficent theoretically. But you also inherit the mistakes of your ancestors, who will simply pass on to you whatever they know, whether it's right or not. It's their best guess. So I was taught Euclidean geometry, which includes the number system, which is very strongly related to Euclidean geometry. It's called linear mathematics. Linear, based on the straight line, with which we're all heartily familiar. Some of us sick to death. What happens is, by the time of high school, you're introduced to the strange world of calculus. And calculus is a most interesting system. Everything in cutting-edge physics right now, both in quantum mechanics and in astrophysics, is based in calculus. You must master calculus. That's not easy to do, because calculus is extremely difficult to define, and it's extremely difficult to use correctly. And calculus destroys the lives, I believe, of millions of young Americans, because the system demands that you learn calculus or you can't make a living. But it goes well beyond it, just the foibles and miraculous applications, you'd have to say, of the calculus. There's also the complex number system, which is exclusively used in quantum mechanics. No other number system dominates quantum mechanics the way the complex number system does. Now, just to mention something in this connection, because this affects millions of innocent children, both now, in the past, and in the future. The calculus system has got to be tamed. That actually cannot happen because of the irrational disposition of human society right now, which is beyond recall, and so is science. And so nothing is actually going to change in the way it should. And I'm sure you're used to that feeling of despair, of hopelessness. That has to be addressed. Whether it can be solved or not is somewhat of a moot issue. It has to be brought to the surface of attention and consciousness so that we're aware of what's being done to our youth, to our children, in forcing them to learn calculus and complex numbers. I have solved that problem. So this goes deep. Quick mention of my environment. First of all, you may hear some noise in the background. There is nothing that I can do about that noise. This is an extremely noisy town, and there are at least 4 or 5 major interruptive noises which you will hear throughout my presentations. This is the hot season. It's late July. This is the 22nd day of July in Northern California in the Sacramento Valley Basin. It's on the average 100 degrees every day at this time of year. I can't close the door or turn on the air conditioner. I can't afford air conditioning, so I can't close the door. So you're going to hear every single noise, including the helicopters, the sirens, the trains, the hawks, the jays, the music, whatever, in this case a buzzsaw. There's nothing I can do about that. I've given it a great deal of thought and effort to correct that, because you don't want noises in the background when you're trying to deliver a synthetic sequence in science, which this is. This is a synthesis sequence, the highest form of science, at the cutting edge of the most important applications of science, going well beyond anything you hear on YouTube. This goes to the subjects of consciousness. There's a siren. Consciousness, reality, the nature of the universe, the force balance system of the universe, the nature of infinity, what the James Webb Telescope is trying to probe, the nature of dark matter. Let's get right into it. I'm going to scroll up through this so that I don't spend an inordinate amount of time on any one province or aspect of the enormous field I must now convey to you somehow quickly and efficiently, but as completely as is necessary for the sake of Occam's razor. Parsimony is the term. The discovery and application, first of all, you have to know the term intrinsic geometry. As I just told you, that actually has a false definition in Wikipedia, although they're simply reporting what the mathematicians tell them. Don't blame Wikipedia for what they're forced to print. I have extremely profound insights into the number systems in use. I discovered the proportional number system, which is extremely pretentious of me to say superficially. I'm just going to continue because I'll be expanding on all of these fantastic topics. The Einstein space-time equation is the basis of relativity, of which there are two versions, but they're both based on equations in systematic linear form, which simply means it's a four-component number system for space-time. If you're already aware of that, that may sound boring, but it may be news for people who have never been told what is space-time. It is a four-component number system, and that's all it is. The Einstein energy equation is E equals mc squared. That can be rewritten to tremendous advantage, and I'll be showing you how to do that again. The Einstein energy equation completes that section of what I wanted to just broach to you, so you know what is the applicability of this intrinsic geometry that I discovered for curvature space, not linear space. The basis of reality is curvature, not linearity. That was not realized for 2,500 years. The important aspect is I can prove everything I say, and that alone is science. Dark matter. I'm merely bringing in this term dark matter to show you the extraordinary reach of this new geometry, because I solved the mystery of dark matter, imaginarity and infinity. This is to broach the cutting edge of where I'm at right now in terms of what I've discovered, and I have proofs for. I can now define infinity rationally. That's the first time anybody has ever defined infinity so that it's now useful. Imaginarity is brand new. Although you know that it is known of, I can define imaginary space, and that's a major breakthrough, and I'll show you why. Consciousness and reality. I have developed a framework capitalizing on the immortal work of Dr. Bernardo Kastrup, who invented a framework that takes the place of physicality, sometimes called materialism. Really, what it is particulateness, or particle framework, which is the framework of matter in terms of atomicity. And we'll be covering all of these fantastic terms so they'll make sense to you. That's the nature of my work. It brings understanding at all levels. The collapse of the wave function is the one solution that Paul-Édouard Maurice Dirac left as his legacy. He tried to solve it. He could not. The Schrödinger equation, both the time-independent and time-dependent forms, form the basis of the cutting edge of industrial science right now. The collapse of the wave function is the only problem that needs to be solved. Currently, all of the top mathematicians, unashamedly, even on the Kurt Jaimungal show, the greatest of all the science interviewers on the YouTube circuit right now, by far is Kurt Jaimungal, among some real greats. And this is the beauty pageant contest sort of thing. It's subjective, and I shouldn't do this, but it's rather forced on me to gain your interest. I've solved the collapse of the wave function. The universal reference frame closing off this particular sequence is what Einstein sought. And his legacy is that quantum mechanics is fucked in the head, and they need to do something. They have been unable to address what Einstein demanded. The EPR paper, Einstein, Podolsky, Rosen, is still at large. In 2022, in October, the Nobel Prize in Physics was awarded
to bury Einstein forever,
so that the many worlds interpretation, MWI, it has some more accurate names, but that's the sensationalist interpretation, which is fully accepted at the cutting edge right now, is the correct framework for explaining quantum mechanical phenomena, including entanglement and indeed the collapse of the wave function, is based on splitting the universe. Now, of course, that can't be exactly what is meant. It's psychotic, a sign of disease. Bernardo Kastrup is the man who directly addresses that at the foundational level, but he made a slight miscalculation based on inevitable prejudice, which must exist because we're facing a system of paradoxes. And the only way you can solve a paradox is the method that I will show you, which I discovered. All right, we're going to go on to another frame sequence. Thank you for your patience thus far. That was over a half an hour of introductory material to what I'll be doing in this series all the way through Christmas, as I envision, maybe less, maybe more, until this paper is published. This paper will be published in phases, probably weekly. It could go to daily, as every single day I expand the document. It will be published so that you can get it. And not only will you be able to download it and read it, you will be able to comment on it in place so that your comments become part of the document. This can be done with the Google system. Google, for whatever else it might be, has provided some extraordinary tools to a serious scientist. And one of them is called Google Sites, where you can set up, if you know HTML, CSS, and maybe a little JavaScript, really all you strictly need is HTML, in order to make your own open source site for free. That you don't need GoDaddy or some of the others that I've used, all of which are reputable, but they cost money. And there's a certain amount of learning overhead for any organized system that produces a bona fide website for you. You're the manager of the site. You can do that for free using Google Sites. It's also integrated with Google Docs. And this gives me the capability, which is fully tested. I actually ran a simulation of this just a little over a year ago when I was attempting to produce my paper. Now, that can't be done through what are called normal channels. And that's because of the tremendous overhead that's incurred by anyone offering to publish scientific papers, because you're going to be swamped. Everybody wants to publish a scientific paper because everybody has their own view at the level that you're at. You're at least interested in discovery science because it's the most exciting aspect of science and constitutes what is accurately enough called true science, to get solutions for you, for all of us. I am not connected with the industry. I'm not even connected with a university, although it is possible that I could get sponsorship from our local university here in Chico, California. The California State University System has a campus here, and I've talked with some officials, including a Russian physicist who was interested in my work, but I didn't have a paper. And you have to have a paper. I also went to the radio stations and secured, I got kind of lucky in one of the men I talked with. He was interested in what I was interested in too, and he agreed to interview me, and then routinely, calmly asked to read my paper, which I did not have. So all of that fell through. And then I thought I was going to be able to publish on arXiv, relatively open source. It's not part of the closed industrial system such as Astronomy and Astrophysics Journal. There's a lot of mathematical journals. You have to already be connected to publish there because they can't just take anything from the public. They would need thousands of dedicated reviewers. And even then it would be hit or miss. So that has to be tightly controlled, and that's just the nature of the game. So I'm forced to publish independently, but that's okay. We have the internet. It's a little less formal because formal, industrial, technologically oriented, government-oriented science, which is 99% of it, it's in a state that it cannot recover. Another siren. And here is to show you how I have set up my technologically innovative system of presentation. You see in the upper left-hand frame, as I scroll, it's also scrolling the lower frame. That's so you can read the separate lines. So much for that. We now proceed into the actual geometry that I discovered. Remember, it is so far-reaching that I have had to develop a system of presenting this to you so that it doesn't just run off in all directions. As I am presenting it to you, essentially planar geometry. This is what we were taught in school, planar geometry. There are some terms that I'll be using, which I'll simply introduce at this time, so you'll be prepared for some multisyllabic geek terms. Parameterization. I will be describing to you why it's important to understand the parameterization of the plane. And then metricization. That's a very specific term that needs to be used because it's the only right term to describe what is being described. I know these are learned terms, they're multisyllabic, rather remote terms. They need to be mastered to some threshold. My job is to make this easy. But I'm giving you the hard stuff first so you'll be prepared for some rather depressing sounding words. I will make them exciting for you. The plane. Let's scroll up. The plane. What is the plane? That's a rhetorical question. We have planar vision. The physiologists discovered this in the 20th century. We rather already knew it, but it's nice to have the proof that we see a flat screen image in our mind. Going to mind, consciousness, internal representation, goes way out there, way fast if you let it. We're gonna let the hydrofoils up, and we're gonna go at hypersonic speed soon enough. But you don't want to do that too quickly. We go all the way here. We get solutions to the most fundamental and exotic questions that humankind has ever asked, some of which go back to our very nature, such as consciousness. We're getting there, but that's really somewhat in advance of what I want to show you, which is more nuts and bolts, such as planar vision. The reason we understand movies so well, that if it's presented that there's a train coming toward you on what is nothing but a flat screen image, either on your computer or on a movie screen, a drive-in movie screen is the example I like to use, because you can get out of your car and walk up to the billboard, this is just a whiteboard, and look at it sideways. Yes, that is a plane. And P-L-A-N-E, a flat surface, which has on it, when the movie is running, images so powerful that if a train is shown coming toward you and it's timed just right, you will jump out of your chair and you won't be able to stop your body because it can't tell the difference between a movie and reality. And that's profound. We'll get there. But all this goes to synthetic idealism, which is the reconstitution of universal space with consciousness as the axiomatic basis. That's Bernardo Kastrup's discovery, and I simply have extended it. The plane, volume, and hyperplane systems That's a lot of shit that I just dropped on your shoe. The plane we just discussed, volume space is typically called 3D. You hear that all the time. That's a valid term, but it's linear systematic space. This is the line. The second line makes the plane by parameterization. And the third line, which just looks like a dot because you can't see it, that's depth. And that's the third dimension in systematic spatial space. All right, let's go on to the next line. I have to be summary here. I should complete the sequence, though. Then I have the word hyper, which is simply short for hypervolume. You may or may not have heard the term hypervolume, but hyper simply means a super. It's a super space relative to the space you're referring to. So if you start with a plane, the hyper volume of the plane is 3D. Well, there's a hypervolume to that called 4D, which introduces an imaginary axis, which Einstein used to call it time, from which he made hypervolume space called spacetime. That's a hypervolume space where the fourth orthogonal axis or vector is time, not space. We'll come back to that. The next line down, we have Euclidean geometry in a nutshell in a way it's never presented, which is by putting the plane first. This was Euclid's mistake. He did not begin with a parameterization of the plane. Instead, he began with a parameterization of the line. And the parameterization of the line is quite simple. It's the point. So he began his famous book, Elements, with an axiomatic definition of space based on the point. And that's a mistake, which I discovered. The planar edge. When you're talking about the plane, what exactly do you mean? If it's a blackboard or this surface here, which I hope my pointer is pointing there, yes. That is a rectangular planar section. So what's the edge of that plane? Well, it's not the edge of the plane, it's the edge of the planar section. So how do you do that? Well, in this case, it's done with rectilinear extrinsic geometry. That's incorrect for physics. You have to begin with a curve called a circle. We're getting there. So when you're talking about the plane, you're talking about the edge. But if you're talking about the edge of the plane and you begin with a line, you have a Euclidean point at the Archimedean balance of the line. That's a mouthful of words which may not make perfect sense to you at this moment. The term Archimedean is my term. I invented that term. The Archimedean balance of a space is something that can be defined. And for the plane, that would be the center. But if you begin with a line, you get a Euclidean point at the center of the plane. And that means you have rectilinear extrinsic geometry called the Cartesian grid. That does not work for quantum mechanics or for astrophysics. It has to be based on a curvature line called a circle. And now we begin to talk about the line itself, which has two utterly different definitions. Get used to that. What is a line? Well, if you draw a curve, is that a line? It is if you define a line as something you can draw on the plane, which is the correct definition of a line. So a line does not mean straight line. Line means line. And a straight line is a very specific example of the family of lines, and it's unique. It's a zero curvature line. And we'll go down here, another line, another use of the word line. There are two types of line, open and closed. The straight line, the linear I'm sorry, the Euclidean line is an open line. So is a hyperbola. There are only 4 types of line on the plane. A zero curvature line called a Euclidean line, a hyperbolic line, a parabolic line, and then the family of closed lines called the ellipses, which collapses to a circle, but not to a point. And that's a major discovery because it defines the quantum correctly. The curvature family. There are 2 ways of measuring curvature which are in use. One of them is called curvature. So one of the ways of measuring curvature is as curvature, and Gauss discovered the way to do that. And so if you're classifying the lines by their curvature, then the straight line is zero curvature. You can also classify all 4 types of planar lines, which is redundant because all lines are planar. You can classify them by eccentricity. And you may be able to see there, I should have this a little there. I think you can see highlighted, that's infinite eccentricity. That's the Euclidean line. When it's measured for curvature, but not using curvature, rather using eccentricity, then instead of having zero curvature, it has infinite eccentricity. We will be coming back to all these things to explain them fully. Here we have a line that just has 3 words, apparently in random order: the metric, the unit, and the quantum. This has to do with metricization of an object, which in this case would be the line, but now you know I have redefined the line. So this has 2 applications. A metric is what you measure. For instance, distance is a metric. Then you have the unit of the metric. This would be the base unit, such as 1. It is the most obvious. That actually is the definition of unity. It's the first unit in a metric, which we're very accustomed to thinking of as a linear sequence of numbers beginning at 1, and then you simply add 1. So you get 2, 3, 4, 5, 6, etc. Now the quantum is a specific kind of unit. It's the smallest unit that you can have for the metric. That's called the quantum unit, or it's just abbreviated quantum, and that's a noun. It's not an adjective. It's a noun for a kind of unit, which in microphysics, going to the smallest of everything, eventually you reach the smallest measurable unit, and that will be the quantum unit. Currently it has several definitions based on essentially the dimensionality of the space. You have the Planck length. That is a quantum unit of length. Has a very interesting definition. And there are several others, and we'll be covering those. So now we have the word quantum, which now can be used as an adjective. And probably the most famous or sensational of the adjectival uses of the word quantum is the quantum jump. I won't go into that now because that really gets deep fast. You also have quantum space, and this would refer to the Planck length for Euclidean systematic extrinsic spatial metricization. A lot of words for some stuff that's actually quite simple. My job is to make this simple, but the words, you have to at least be exposed to the words that I'll be using so that they will make sense when you hear them being used in context. And from there we go into what I discovered, which begins with the circle and then goes immediately to the sphere. And then it goes to the hypersphere, which takes the place of spacetime. Spacetime is a hypercubic system, hypercubic, whereas actual physical space is hyperspheric. and it has an imaginary component. And imaginary space is the most exciting, in my opinion, of all the terms we've broached thus far, which is a hell of a lot. So here we have a little bit of the framework that we'll be using in this series, because this is a publication sequence for you to get my paper at all phases of development. The two systems that I will be using in order to produce, if I do this right, oops, let me make sure I press the right button here. I want to highlight these words and roll it up so you can see them. GitHub is the second site that offers a free website, and you can make as many of them as you want. I know this sounds fantastic, but it's true. It's rather a recent service offered by GitHub, which is, of course, I'm sure you've heard of GitHub, and if you haven't, you will. That will be one of the sites where I have tested a full-fledged website for the production of my paper. So GitHub uses a system called Pages. That's their term. And therefore, my site is called a GitHub page. I will be giving you those links, although if you looked into the archive of my public videos, you would be able to find that, but you won't find much there because it was a prototype. The other system is Google. Google is, of course, famous and in some ways infamous, as we all know, or you might, but they offer something called Sites, and therefore I have a Google site. And this has a web address and it's safe. Both these systems are safe, although nobody's perfectly safe. And there's a topic I could comment on, but I won't because it's kind of insidious. Now down here you'll see some technical terms. Libre Office is the editor that I use. It essentially inherits all the functionality of Microsoft Word, which has predecessors and successors, but Libre Office is, in my opinion, the cutting edge of open source editors. I use Libre Office rather than OpenOffice. OpenOffice used to be the most famous one, but there was a fork. That's the right term for it, a fork, where some developers decided to modify OpenOffice, and they called it LibreOffice, and now that's taken over. It's by far the most sophisticated editor I have ever used, and I've used all of them. So, the term in brackets is the typeface I'll be using. Deja Vu Sans is the name of a typeface, sometimes called a font, but that actually refers to the size of the typeface. LaTeX is a term I'm sure you've heard. It refers to a couple of functionalities. LaTeX is capable of producing exquisitely formatted equations, and I use it for that purpose, and I will be using it in the paper. There will be the source code so that you can actually rewrite everything that I write if you would prefer to write it yourself, perhaps for learning purposes. LaTeX also has a layout functionality so that LaTeX is used for formatting scientific papers. I will be using LaTeX for the format framework for my paper, but it's not greatly involved. LaTeX can either be extremely simple or as complex as you like, so it's quite versatile. And I will be using it both for layout, but very simply, and for the equations. And we'll be dealing quite a bit with equations. All right for that. All right, and now we've reached 1 hour. I never am positive how long one of my videos will take. My natural cadence or rhythm is 2 to 3 hours. That's a bit much. I have tried to pare it down to 40 minutes to half an hour, and it looks like when I shoot for 40 minutes, it ends up being an hour. So we're closing in on an hour now, so I'm going to wrap this up with just what you can expect in the next video to come, which I expect will be later today. So this is the first in a indefinite number of videos in a series in order to document the production of a scientific paper for a major discovery. I'll just say it's just one for now, but it's many. In order that you may follow from inception to release, from inception to publication, the full cycle of a formal scientific paper. This continues what I began 4 years ago to document a scientific discovery from inception. It was meant to be to publication, but that's been delayed until now. And I see we have some more noise beginning outside, so we're going to close this off. I want to thank my listeners. I have a dedicated following of at least 4 listeners now, which is a monumental improvement on 0, which it had been the case for the first 3 years. Some of that's quite natural. Some of it's due to the fact that I'm dealing with something that's not what you would call a titillating topic, geometry, ho-hum. Yeah, but space-time is a little bit more to the nerve of things. And consciousness, I think you should start telling your friends and your professional acquaintances, some of whom you may have to seek out and meet in order to give them my name, my site, what I'm doing, and give some kind of explanation for why they cannot afford to overlook me anymore. I do not ask for money. And that's quite an important emphasis these days, because everybody else does. That's not strictly speaking true, but most of the people who produce and don't ask for money don't have anything worth offering, quite frankly, unless you like music videos or something to do with someone falling and breaking their ass. There are a lot of excellent YouTube stations, such as Topo Traveler, if you're interested in exploring the Colorado Plateau, but you don't want to be fried alive. You can capitalize on this video station. There's also another producer, POV, and I can never remember the second word, but you can find this if you look for hikers who look for anomalous geologic features on the Earth, many of them being on the Colorado Plateau, not too far from where I live. Some amazing stuff of nature, which is really what we're interested in, isn't it? It's not just the universe, which is huge, but the Earth. The heavens and the Earth, the cycles of the planets and stars in the sky, vastly interesting to every real man. This is the nature of being a real man. You're interested in the cycles of nature because you know there's information there that you must know. And this goes to religion. The basis of all religion is the cycles of nature. This is Anagalactic, bringing you the secrets of the universe, now to be revealed in a formal paper, and you'll be able to accompany this process to the incredible enrichment of your soul. Thank you for tuning in. Leave comments. We'll be right back. Thank you.